right, in this lesson we are going to talk about angle-side relationships in triangles. So let's go ahead and take a look. So in our first situation, if two sides of a triangle are not congruent, so the sides are going to be different, they're not going to be equal in length, then the larger angle is opposite the larger side. So let's take a look at our triangle over there, triangle ABC. The largest side is side AC. That means angle B is the largest angle in this triangle. So angle B is the largest. Well, the same works for small. If I look right here, side AB is the smallest side and the angle opposite is angle C, which makes angle C the smallest angle. And since side 8 fits between 8 and 12, I know angle A would be in between angle B and angle C. Let's take a look here. If two angles of a triangle are not congruent, then the larger side is opposite the larger angle. So just thinking about it in terms of the angle first. Let's look at our picture. Triangle DEF. I'm going to go ahead and find angle D. The measure of angle D is going to be 180 minus 68 minus 42. So 180 minus 68 minus 42 gives me 70 degrees. Well, it looks like angle D is the largest angle. So if angle D is the largest angle, then this side, FE, is the largest side. So FE is the largest. And if I look at the smallest angle, well, my smallest angle right here is 42 degrees, and the side opposite of that is DF, which makes side DF the smallest side. So there you go. That's how we deal with angle and triangle, or angle and side relationships of triangles. Let's go ahead and take a look at a sample problem. So in this picture, we're given triangle ABC, and we're told that side AB is 7 and side BC is 18. The measure of angle A is greater than the measure of angle B. So measure of angle A is greater than the measure of angle B. And I keep reading. It says the measure of angle B is greater than the measure of angle C. So it appears that angle A is the largest, so I'm just going to put an L so I know it's the largest. And angle C is going to be the smallest, which means angle B is kind of in the middle. Well, our job is to find the possible values for the length of side AC. So here is the side that I'm talking about. Well, we just figured out that AC is not the largest or the smallest, it's the middle length, we can say. So that means that side AC, well, it can't be bigger than 18. So it has to be less than 18. But it has to be bigger than 7 because it's not the smallest. So it has to be greater than 7. So there's our first inequality. When we're doing these, we also have to think about another inequality that we've learned called the triangle inequality. And remember, the triangle inequality theorem states that any two sides of a triangle, when added together, has to be greater than the third. So that means whatever AC is, when I add that to 7, that better be bigger than 18. So I'm going to go ahead and find what that would give me. I'm going to subtract 7 from both sides. So AC has to be greater than 11. Well, in my first situation, I just said AC had to be bigger than 7, but that's not true. 8 is bigger than 7, but if I take 8 plus 7, that's not going to be bigger than 13. So when we do these types of problems, we have to not only think about the angle-side relationships, but we also have to think of the triangle inequality theorem. So my final answer is AC still has to be less than 18, but based on the triangle inequality theorem, it has to be greater than 11. So there you have it. Good luck on the rest of this lesson.